Hello everyone. In this video we are going to learn about the restricted permutations. In the previous video we have already learned about the permutations. What is the meaning of permutations and how to find out the permutations of n objects altogether or taking r of them. Now we are going to learn about the restricted permutation. What is the meaning of restricted? Restricted means there are some conditions given. What type of conditions may be there? That sometimes we are given that the objects or the numbers are repeated or letters are repeated. Maybe that specific places are given for some of the specific objects. Or maybe that some of the objects are always together and so on. We will be learning all these things one by one with some examples. So please watch the video till last so that you can understand everything, every type of restrictions and the way we can solve the problem. And if you have not subscribed the channel so far, subscribe it so that you can get this type of more videos on different topics of mathematics. Let's go to the first condition or first restriction now, that is when repetition is allowed. In what way we solve this type of problems? See, we take one example. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6, 7 and 8 if repetition of digits is allowed? So the conditions have been given here. First, that the numbers are to be even. Second, that the repetition is allowed. What we will do? We know we have been given total 8 digits. Total number of digits which we have been given are 8. See, for an even number we know that the unit place is to be filled with a digit which is a multiple of 2. For even number, unit place is a multiple of 2, or we can say even number. And such digits we have, they are 2, 4, 6 and 8. They are only 4. It means when we want to form the 3-digit number, we know that we need 3 places. This is the units place, this is the tens place, this is the hundreds place. And out of these 4, 2, 4, 6 or 8, any one can be placed here at the units place. It means unit place can be filled in 4 different ways. And then any number we are making, that will be an even number. After filling this units place, we have to come to the tens place. Now since repetition is allowed, it means any one of these 8 digits can be placed here and that can be done in 8 different ways. Similarly, hundreds place also can be filled in 8 ways because repetition is allowed. It means 3-digit numbers which can be formed will be the multiplication of them because of the fundamental principle of counting. So we can say therefore number of 3-digit even numbers is equal to 8 into 8 into 4, which is equal to 256. And this is the answer to the problem. It means we have understood in case repetition is allowed how the objects can be placed. See, the next restriction we may have when some of the specific objects are to be placed at some specific places. For example, we are given a question, how many words can be formed from the letters of the word triangle which start with T and end with E? It means T and E are to be at the specific places, that is first place and the last place. For the solution of this, what we do, we know we have been given the word triangle. The total number of letters in this is equal to 8. And when they start with T and E, then we can see that we are to arrange only remaining 6 in between them. For the words to start with T and end with E. See here, like this is T and this is E. And we have 6 letters, 1, 2, 3, 4, 5, 6. These places are to be filled with these 6 letters. And that can be done in how many ways? That is 6p6. So we write here, for the words to start with T and end with E, the other 6 letters can be arranged between them in 6p6 ways. Therefore, total number of such words is equal to 6p6, that is factorial 6, or we can say equal to 720. So 720 words can be formed which will start with T and end with E, taking all these letters of the word triangle. See, the next restriction we may have, like suppose we have n objects, and out of that some of the objects are always to be together. We have to arrange all the objects. Like suppose we have n objects and out of them m objects are to be always together. Then what we will do? We can consider these all m objects as one object. It means what? It means the total number of objects with us will be equal to n minus m plus 1. Out of n we have subtracted m, and that m are acting as one particular object now. It means now we have to arrange only n minus m plus 1 objects which are to be arranged all together. Therefore, permutations of n minus m plus 1 objects will be equal to n minus m plus 1 p n minus m plus 1. But we have to remember one more thing, that these m letters or m objects which are together, they can also be arranged in m ways. But m objects can also be arranged in m ways. And therefore, total number of permutations in such case will be m into n minus m plus 1 p n minus n plus 1. For example, here we can consider the same word triangle, and now we have to make the words when the vowels are together. We know the total number of letters in this is 8, and the number of vowels, that is 3, because that is I, A and E. If all the 3 vowels are taken as one letter, then the total number of letters in this will be 8 minus 3 plus 1 equals 6. That is n minus n plus 1. And these 6 letters can be arranged in 6p6 or factorial 6 ways. So we can write therefore total number of permutations will be equal to 6p6, which is factorial 6, or you can say 720. But these three vowels can also be arranged in factorial three ways. But three vowels can be arranged in 3p3, or we can say factorial three ways. And therefore, the total number of such words will be, therefore, total number of such words will be 720 into factorial 3. That is 720 into 6. That is 4320. It means 4320 words can be formed in which vowels will be together. Now suppose you are asked to form the words in which the vowels are never together. Vowels are never together. In that case, what we will do? We will find the total permutations of 8 letters. That is, you can say without any restrictions. Will that be 8p8, or you can say factorial 8, which is 40320. Out of which, with the vowels together, are 4320. When vowels are together, number of words is 4320. Therefore, the number of words when vowels are never together will be equal to 40320 minus 4320, which is equal to 36,000. It means 36,000 words can be formed when vowels are never together. The next restriction may be when some of the objects are never to be together. See, like we have an example here. In how many ways 5 boys and 5 girls can sit in a row when no 2 girls sit together? In this type of problem, we have the number of boys 5. Number of girls are also 5. When we know that girls are not to sit together, we will find the places for the boys. Like this is the first place for the boy, second place, third place, fourth place and fifth place. These 5 places are to be occupied by the boys. In how many ways we can do this? 5p5 or factorial 5 ways. So we can write 5 boys can sit in 5p5, or you can say factorial 5 ways. Now for the girls, when they are not together, how many places we are having for the girls? Like this we can see. 4 girls can sit between them. But there are 2 more places, one before the boys and one is after the boy. It means there are 6 places in which the 5 girls can be arranged. And how many ways? Out of 6, 5 places are to be occupied. That will be 6p5. So we can write, for the girls, we have 6 places in which these 5 girls can sit in 6p5 ways. And 6p5 is same as factorial 6 because it is factorial 6 upon factorial 6 minus 5. That is factorial 6 upon factorial 1. So we can write 6p5 is same as factorial 6. It means how many are the total number of ways? Therefore, total number of ways will be factorial 5 into factorial 6. We know factorial 5 is 120, factorial 6 is 720, and we can multiply and get the answer 12 to the 24 to 84 into 86. So this comes as 86,400 ways. It means 5 boys and 5 girls can sit in a row in 86,400 ways when no two girls are together. The next restriction is when one object is always included. Suppose there are n objects and out of them r are to be arranged, but one specific or particular object is always included in that. In that case, what we will do? See, we have r places like this. The particular object which is always to be taken can sit at any one of the place or not. Suppose the object is placed at first place. Then we are left with r minus 1 objects or not. And from the n minus 1 objects we have to arrange these r minus 1 objects. So n minus 1 p r minus 1 will be the number of permutations for that. Suppose this comes at the second place. Then again we have the same n minus 1 p r minus 1. It may go to the third place or fourth place or rth place. It means this can occupy any of the r places in r different ways or not. And hence we say that the number of total permutations in such cases will be r into n minus 1 p r minus 1. Let's take one of the example now on this. How many 3-digit numbers can be formed from 1, 2, 3, 5, 7, 8 which have 5 as a digit? It means 5 will be always a digit in that 3-digit number. Now, you can see 3-digit number means we need 3 places. This is unit, this is tens, and this is hundredths place. 5 can be at any place of this. It means 5 can occupy any of the 3 in 3 different ways or not. Total number of digits we are given, digits, is equal to 6. Out of these 6, 1 5 is to be at any place, or this is to be always there. Since 5 is always there, then the remaining 2, only 2 places we need then. 2 digits from how many? From 6 minus 1, that is equal to 5 digits can be arranged in how many ways? In 5p 2 ways or not? N minus 1, PR minus 1. 6 minus 1, 3 minus 1. But this 5 can occupy any of the places. 5 can be placed in 3 ways. Therefore, total number of such numbers of 3 digits will be how many? There will be 3 into 5p2. That is 3 into 20, because we know 5 into 4, 5p2 is 20. 3 into 20 is 60. It means 60 different numbers of 3 digits can be formed, which always have 5 at any of the places. Like this, many of the restrictions can be given, but only the thing is we have to understand the restriction and then we have to apply the permutations to that particular problem to solve. Now in the next video, we will be learning about the circular permutations. What are circular permutations and what type of problems we can have on circular permutations and how to find out the solution of them. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.